Victoria Lyons, and today I'm going to talk to you about the history of doorbells. First up, we have the common door knocker most people are familiar with. It's a hinged knocker attached to a metal plate on the door. You just knock it, it makes a nice loud sound. Next up, we have the mechanical doorbells. Common form of this that most people are familiar with are the servant bells. You see them a lot in movies from the Victorian era, late 1800s. Next up, we have Joseph Henry. He invented the electric doorbell in 1831. He was a secretary of the Smithsonian scientists. He worked a lot with magnetics. He developed an electromagnet to be used in doorbells. After that, we go on to 1900s. Batteries were replaced from transformers, so you can use the household current in your home to run the doorbells instead of batteries. After that, we go on to the 1930s, when chime doorbells become very popular. And from there on, doorbells just get more and more sophisticated. You have 1960s, you have multifunctional doorbells where there's clocks built into them. And they're designed more for decorative purposes, decorative plaques to cover up all the wiring. And from there, we go on to today's doorbells, which does all kinds of things. You can change the sound of your doorbell, to change the look of it, even video who's bringing your doorbell.
Hi, I'm Sherry Nunez, and I'm going to talk about the push button. The button's used to activate the chime or of the monetary switch type. Think of it like you could remove the switch and manually touch the two wires, open-ended wires together, therefore completing the electrical path to activate a chime. Add the switch and it achieves the exact same thing, momentarily completing the electrical path when depressed to energize the chime, then breaking the electrical path when released as the internal contacts no longer join.
My name is Daniel Ganshaw, and today we're talking about the AC mains unit and the transformer. So the AC mains unit is the main power source for the entire doorbell system, and it goes into the primary coil inside the transformer, which is a coil that's wrapped around the iron core inside of it, and then once that gets charged up, it goes to a secondary coil, and once that charges, it changes the magnetic field within the transformer, which then induces a voltage in the second coil, and that voltage in the second coil then goes back to the circuit connected to the whole system.
Daniel Jones, and I'm going to talk about this part in the doorbell circuit. What you have is a piston surrounded by a coil of wire that is called a solenoid. When the coil of wire is powered by electricity, it propels this magnetically conductive piston towards this chime. And then the spring right here, whenever you let go of the button, propels it back towards this chime. It makes the ding-dong sound that doorbells traditionally are known with. The clip of the mechanism in action.